Hello, and welcome to video number 5. So, this word problem is going to be a little bit more challenging than what we'd normally expect to see. But if you can solve this problem here, you are more than prepared for the test that we're going to have. The study guide really is meant to help you guys study, but it does include some particularly challenging problems. This was done on purpose really just to get you guys to practice some more. But if you can follow along and you can successfully solve this problem, you are more than ready for this test. All right. Let's go ahead though and take a moment and look at our question here. So, the average emissions of CO2 in grams per kilometer traveled by a passenger vehicle in Denmark for 2001 and 2019 is shown. We're seeing in our table here, we have the year in our first column, and then we have the average emissions of CO2 in grams per kilometer in our second column. What we need to figure out is, or what we need to determine rather, is the difference in the average emissions of CO2 in grams of 30 passenger vehicles in 2019 and 30 passenger vehicles in 2001. All right? So, first thing I'm looking at right now is that we have some mixed numbers. With these mixed numbers, I don't like to work with mixed numbers because the math can get a little bit wonky and mistakes can happen. So let's instead take our mixed numbers and turn those into improper fractions. So to do that, we gotta multiply, then add. So when we're multiplying and adding, we're going to start off by taking 12 and we're going to multiply that by 174. When we do that in our calculator, we get 2088. If we take that, then we're going to add our numerator, which is going to be 5. So this gives us 2093. So that's going to be our numerator, 2093, over our denominator of 12. All right? So this is our first fraction, our mixed number now as an improper fraction. Let's go ahead and do the same thing for our second fraction. We have 107 times 4, because again, we're trying to do that multiply, then add. So if we take that times 4, we get 428. And then we're going to add our numerator. So we're going to add 1. When we do that, we get 429. So that's our numerator. And the denominator stays the same. So our denominator is going to stay as 4. All right. This represents the average emissions of CO2 in grams per kilometer for just one single person. For this question though, we need to figure out how much this was for 30 passengers. So we need to take both of these fractions and we need to actually multiply them by 30. All right. So both fractions need to get multiplied by 30. Now, whenever you are multiplying by a whole number, you can just take the whole number and write it with a 1 under it. So you can write it over 1. We can do that with both of these here. And then for multiplying fractions, you can just multiply straight across. So let's go ahead and take our first fraction here. We have 2093. We're going to multiply that by 30. So when we multiply this by 30, our first fraction, I'm going to go ahead and write it down over here, is going to be 62,790 over, and then we have 12 times 1, so we get 12. All right. Our second fraction, we're going to take 429 times 30. So when we do that, we get 12,870 over, we can take 4 times 1. This is going to give us 4. All right. So these are our two fractions now, showing what was happening in each of these years for 30 passengers. Our goal, though, ultimately is to find the difference. When we're trying to find the difference between two numbers, that means we are subtracting them. So we need to take these two fractions and subtract, but if we're trying to subtract them there, we need these to have the same denominator. So for these to have the same denominator, we have to find our least common multiple. You might also hear this referred to as the least common denominator because we're talking about the denominators of our fractions here. They're both the same thing. I just refer to it as least common multiple because that's how we first taught it to you guys. But let's go ahead and look at finding the least common multiple of our denominators for these fractions. And to do that, let's do our L method. So let's start with 12 and 4. So when we're looking at these two numbers here, I want to see, is there a factor other than 1 that can go into both 12 and 4? In this case, yeah. There's actually a couple of factors here, but I'm going to just use the factor 2. So I want to show you guys something. If we have 2 here, what we want to look at now is how many times can 2 go into 12? Well, 2 can go into 12 6 times. And now we want to see how many times can 2 go into 4? Well, 2 can go into 4 2 times. So we're going to go ahead and repeat now the same question from before. So with our two new numbers, 6 and 2, I want to think, is there a factor other than 1 that can go into both 6 and 2? There is. The number you should be thinking of right now is going to be 2. All right. So what we're going to do, we're going to add another L, or add another rung to the ladder. I like to think of it sometimes a ladder, like the L method for the ladder. Because if you can keep going, you're adding more and more steps to the ladder. We're going to put our 2 over here. And now we want to think, how many times can 2 go into 6? 3 times. And then how many times can 2 go into 2? 1 time. So again, we're going to repeat the same question. Is there a factor other than 1 that can go into both 3 and 1? There isn't. So we can go ahead and stop here. But we're talking about that least common multiple. So for our least common multiple, I kind of like to draw like a bubble L just to make sure I include all the numbers that are making up that L. And what we're going to do here is we're going to multiply all of these numbers to figure out what the least common multiple is. So we are going to take 2 times 2 times 3 times 1. Well, 2 times 2 is 4. 4 times 3 is 12. And 12 times 1 is still 12. So the least common multiple is 12. So for these two fractions over here, we want them to have a denominator of 12. Well, this first fraction already has a denominator of 12. So we don't need to do anything special with that. Our second fraction, though, does not have a denominator of 12. So we need to think, what could we multiply that denominator by so that we get a denominator of 12? Well, in this case here, if we take 4 and we multiply it by 3, that would give us our denominator of 12. But whatever you do to the denominator, you have to do to the numerator. So we're going to take our numerator and we're also going to multiply this by 3. All right? So let's take that 12,870 and multiply it by 3. And when we do that, we should get 38,610. All right? Really big number here. With these two fractions, We are going to go ahead though and find the difference between them. So we are going to go ahead and subtract these. So we're taking our first fraction, 62,790 over 12, and we want to subtract 38,610 over 12. Whenever you are adding or subtracting fractions, your denominator can stay the same. So we have a denominator of 12 here. And then let's take in our calculator 62,790 minus 38,610. So when we subtract these, we should be ending up with 24,180. And then the last thing to do here is just to simplify our fraction. We can simplify this by just dividing it really. We can take 24,180 and divide that by 12. When we divide this, we're going to end up with 2,015. That's going to represent the difference that we are seeing here. All right. Again, this was a challenge problem, so if you can understand this problem, you are more than ready for the test, especially if you were able to just successfully do this problem on your own. If at any point, though, you were kind of confused about what was done in the video, please feel free to pause, rewatch something, or if you're one of my students, please just send me a message over eCampus or email, just letting me know, saying, hey, Mr. Menos, I didn't understand, let's say, I don't know, a certain timestamp, so maybe 3 minutes into whatever video it is that you were watching and you were getting stuck on it, and I'll try to get back to you as soon as possible. All right, see you in the next video.